Hello student, welcome back to lecture series on numerical interpolation, numerical differentiation and integration. So within that already guys we have learned in our channel finite difference. Under finite difference I explain forward difference plus backward difference with some of the examples. Okay. So in our today's video guys I'm gonna explain to you all the next part, which is the central difference. Okay, that actually we are working for finding the solution for our given numerical equations. Okay, so already that I explained here forward and backward difference. Okay, so in our today's video guys I'm gonna explain to you all central difference. Okay, with some of the example. First of all we gonna go and understand the concept what actually the central difference. Okay, so without further ado, let's get dive into our today's lecture guys. First of all we'll see what is the central difference. Okay, now see that guys, central difference it denoted by delta. Okay, delta is a mathematical symbol. Okay, we denote central difference by delta. Delta is like this. Okay, yes, and the first central difference first central difference it is written as or denoted as delta of f of x, and which is written as f of x plus h by 2 minus f of x minus h by 2. Okay, this one is our first central difference guys. Okay, so using this one we have to go for the second central difference, third central difference, and up to the n central difference. Okay, that one we needed for our finding the central difference for our given examples. Okay, yes, now see that this one is our first central difference, and we know that the central difference denote written as the second value of y table minus first value of the from y table. Okay, that we have data set given like x table, y table. Okay, and using this one we have to find out the central difference for the values of y. Okay, yes, so delta of f of x, it can be written f of x plus h by 2 minus f of x minus h by 2. Okay, so delta we denote as the central difference operator. Okay, yes, and so if you want the first central difference, okay, I'll explain to you all in the tables first central difference. Okay, so let's go for the second central difference. Second central difference means we have to apply again delta to this function. Okay, that means second central difference central difference, we apply delta into delta, that means delta square of f of x. Okay, this one is our second central difference, that means delta into delta of f of x. Okay, delta into delta of f of x, this one is our second central difference. Okay, so we want the central difference in the form of like these functions. Okay, so expand this one using this form. Okay, so keep this delta as it is, delta of f of x written as f of x plus h by 2 minus f of x minus h by 2. Okay, so f of x plus h by 2 minus f of x minus h by 2. Okay, so this one is the first central difference that I replace over here. Okay, so again we are going to apply this delta to this central difference. Okay, that means delta of f of x. Okay, so we are going to apply separate central difference for this function and this function. It's work like a differentiation integration rules guys. Okay, so delta of f of x plus h by 2, we write delta of f of x plus h by 2 minus delta of f of x minus h by 2. Okay, that I apply delta here to the first function and the second function separately. Okay, so delta of function, okay, that means delta of f of x can be written as f of x plus h by 2 minus f of x minus h by 2. Okay, so instead of x we have here x plus h by 2. Okay, now let me explain how we can write these values. Okay, we know that delta of f of x as a f of x plus h by 2 minus f of x minus h by 2. Okay, this one is our first central difference. Okay, so I want the value using this one, I want the value for delta of f of x plus h by 2, delta of f of x plus h by 2. Okay, yes, I want this one, delta of f of x plus h by 2. Now see that instead of x instead of x we have x plus h by 2. So wherever you will get the x, replace as a x plus h by 2. Okay, and now see that we have here a delta of f of x. Whenever x is there, we have x over here for these two functions. Okay, but instead of x we are mapping to the x plus h by 2. So replace x as a x plus h by 2, this x as a x plus h by 2. So we write f of x plus h by 2, x as a x plus h by 2 plus h by 2, it remains same as it is. Okay, minus f of x as a x plus h by 2, x plus h by 2 minus x h by 2 only. Okay, this one is a h by 2. See that I replace this value here. Okay, so I want the value for f of x minus f of x plus h by 2 we are replacing here. Okay, so delta of f of x plus h by 2. Okay, that means this x replace as x plus h by 2 minus h by 2 as it is here. Okay, so I written this way. So h by 2 plus h by 2, 2 times h by 2. Okay, that means only h. We write f of x plus h minus x plus h by 2 minus h by 2 can be cancelled here. So we write f of x only. Okay, so delta of f of x plus h by 2, we write f of x plus h minus f of x over here. Okay, yes. Now similarly we have to find out the value for this one. So I found this for this one only. Okay, similarly we have to find it out for this one. Okay, so let's go for this value. Okay, delta of f of x minus h by 2, delta of f of x minus h by 2. Okay, delta of f of, or we can read as a central difference of x minus f of x minus h by 2. Okay, yes. So what we do now here, so I want the value for this one, so apply with a given function. Okay, so we write f of x as x minus h by 2. So f of x minus h by 2, x I replace as x minus h by 2 plus h by 2 as it is over here, h by 2 as it is here, minus x as x minus h by 2, x minus h by 2. Okay, so you have out here x minus h by 2 minus h by 2. Okay, that plus h by 2 minus h by 2, it is cancelled over here. So we write only the f of x minus f of x minus h by 2 minus h by 2. Okay, take negative common, so x minus h only. Okay, and h by 2 plus h by 2, it is only the h. Okay, so this one is the value for delta of f of x minus h by 2. Okay, so replace this value and this value. Okay, replace this both of the value in our given delta square. Okay, now let's see what the value it is coming. Okay, so I'm going to replace these two values over here. So delta square of f of x, delta square of f of x, we write this one as delta square of f of x, we write is delta of f of x plus h by 2, means f of x plus h minus f of x, f of x plus h minus f of x. Okay, and after this we want the f of x minus h by 2. Okay, that means this is the value. Okay, minus f of x minus f of x plus h, give the bracket, so we do not want any sign confusion. Okay, so f of x minus f of x minus h. Okay, this one is the both value. Okay, now what we have, this is the negative sign, so take it under bracket, so we get the f of x plus h. Okay, minus f of x, remove the bracket, so minus f of x plus f of x plus minus h, f of x minus h. Okay, these are the value. So f of x plus h plus f of x minus h and minus 2 times f of x. Okay, so f of x plus h minus 2 times f of x plus f of x minus h. Okay, this one is our second central difference. Okay, delta square of f of x. Okay, I hope you all have understood, guys, how I have written this second central difference. Okay, it's not difficult, just need to replace the values. Okay, yes. Now see that how the value we are going to define. Okay, so see that in our previous case we consider some y1, y0, y2, this sort of the values. Okay, so using this value we have to define the value for y1 and y0. Okay, sorry, using this value, first value. Okay, for first difference, if x plus h by 2, let me consider some specific value for this one. Okay, if x in our last part we consider x plus h as a y1, and if x minus h is there, we consider it as the y0. Okay, yes. So instead of, we have here x plus h by 2, okay, keep it y1, and x minus h by 2 keep it as the y0. Okay, so whenever we take f of x as a y, then f of x plus h by 2 as y1. Okay, so consider it as y1 minus f of x minus h by 2 y0. Okay, so central difference of f of x. Okay, first central difference of f of x, or delta of y. Okay, delta of y1. Okay, so first central difference, or first central difference of our given f of x, we write y1 minus y0. Okay, so similarly we have to do for the second central difference. Okay, this means x plus h. Okay, so you have to consider some value for x plus h, f of x as the some value, and this one as the some another value. Okay, x minus h consider y0, this one is considered y1, this one is considered as a y1, and this one is considered as a y2. Okay, so that it will be easier for us to define the values. Okay, now let me explain all this part. Okay, let me explain all this part in the form of a table, so that it will be easy to remember for you all. Okay, you all of us. Yes, let me take you all in the form of a central difference table. Okay, so in actual in your exam guys, you have to take this central difference in the form of a table. Okay, so that it will be easier for your calculations. So let me explain a central difference in the form of a table, guys. Okay, so mostly you all are getting, you all get the table in your exam. Okay, so for the argument value, okay, the table for x, which is the x0, x1, x2, x3. Okay, yes, and the entry for y, which is equal to fx. Okay, these are the basic value that guys you will get it in your question paper. Okay, yes, using these values we have to find out the first central difference, second central, third, fourth, and so on. Okay, these many central difference. Yes, now see that let me define the argument value. Okay, so we know that if first value, if we consider as x0. Okay, if we consider first value as x0, we consider second value as x0 plus approximate value. Okay, approximation, we call it as the h. Okay, x0 plus h as a second value. Okay, next value we add as approximation again here, x0 plus h as a third value. Okay, yes, that means x0 plus 2h. After that we add x0 plus h plus h plus h, that means x0 plus 3h. Okay, again after that we take x0 plus 4h, x0 plus 5h, 6h, and up to the nh. Okay, n times h, that we are extending up to the value of n. So it is completely depend on as per your given data set. Okay, so you have to take the value for x0 as per your data set. Okay, yes, and about the values for y. Okay, that you will get that values for y as y0, y1 in your table. Okay, y2, y3, and y4. Such a type of the values you will get it in your table, guys. Okay, yes, now this is the main task. We want the central difference. Okay, first central difference, second central difference, third central difference, and so on. Okay, yes, so we go for the first central difference. Okay, and central difference denoted as a delta of f of x. Okay, delta of f of x, or you can call it as a delta of y also. Okay, yes, so first central difference we write first second value minus first value. Okay, preceding value. Okay, and succeeding value, with we need these two values. Okay, that means first central difference we write as a succeeding value minus preceding value, that means we write y1 minus y0. Okay, this one is our first central difference, guys. Okay, see that we did it similar in our forward and backward difference too. Okay, so it is very much important, guys. You all need to understand how can we define the central difference, forward and backward difference too. Okay, yes, that succeeding value minus preceding value, you will get this next entry of our first central difference. Okay, that means y2 minus y1. Okay, after that y3 minus y2, it is our first central difference, next entry. Okay, y3 minus y2, then y4 minus y3. okay. These many values as our central difference, and make sure that we want this value exactly between these two values, okay, exactly between these two value. Why? We are going to reduce all this value up to the up to the single value over here, okay. That means we have to reduce all these values until and unless that we do not get this single value as our central difference, okay. So you have to after that second central difference, how we write the second central difference, okay. Write it as a delta square, okay, delta square of f of x as a second central difference, okay. Now, so whatever the value it is coming from here, it is coming from here, so consider it as the delta of one, call something here 1 by 2 as a different value, okay. Delta of call it as the 3 by 2, anything you can call, okay. Delta y of 1 by 2, delta y of 3 by 2, okay. So call such a variable so that we can take it easily here for our difference, okay. Delta y of 1 by 2, delta y of 3 by 2, delta y of 5 by 2, which is equal to this, okay. Delta y of 5 by 2, delta y of, okay, 7 by 2. This is just a notation, guys, okay. This is just a notation, don't get confused. I consider delta y of 1 by 2, delta y of 3 by 2, delta y of 5 by 2, delta y of 7 by 2, okay. So I consider it as just a notation, that we don't have space here to write everything, okay. So that I'm going to write only their difference specific values, okay. So we want the second central difference, that means delta y of 3 by 2, right, exactly between here, delta y of 3 by 2, okay, delta y of 3 by 2 minus delta y of 1 by 2, delta y of 1 by 2, okay. This one is our second central difference, first entry, okay. Again, do it similarly here, delta y of 5 by 2 minus delta y of 3 by 2, delta y of 5 by 2 minus delta y of 3 by 2, okay. So delta y of 5 by 2 minus delta y of 3 by 2, okay, that one should be coming here, okay. Yes, so delta y of 1 by 2 minus delta y of 3 by 2. So delta y of 1 by 2 minus delta y of 3 by 2, okay. So similarly you have to take their difference here, okay. So which will come here, again take their difference, which will come here, okay. Again take both of them their difference, which will come here, okay. That means this minus this, it will be here, this minus this, it will be here, and again this minus this, it will be here, okay. This one is our complete central difference, guys, okay, table. This is just for your understanding, okay. So once we continue some of the example shift operator, okay, you will be familiar with all the concept, okay. Yes, so I hope you all have understood everything here in my today's lecture, guys. Today's lecture, it is completely based on the central difference, okay. I hope you all have understood. If you want, you can note it down this table, it is important here. And more than this theory part, guys, examples are quite easy, that easily you can solve the examples, okay. Don't have anything there, you just need to take the subtraction between two constant, you will land on easily answers, okay. Yes, now you can see here, if you want, you can refer this entire central difference values, okay. See that how I have solved this one. This is the important for your conceptual understanding, okay. So if you want, you note it down, okay. I hope you all have understood, guys, my today's lecture. Even after, if you found anything confusing, difficult, challenging, let me know in my comment section. And if you are interested to see similar videos, guys, check it out here in I button or in the description box. You will get the complete entire playlist, okay. Yes, so thank you everyone, thank you for my today's lecture.